Differentiation from first principles. In this video, we will take a look at differentiation and define the gradient function from first principles. Let's take a curve and define 2 points on the curve. The 2 points being A with the coordinates x and f of x, and B with the coordinates x plus h, f of x plus h. We can join these 2 points up with a chord. Because this chord is a straight line, we can find its gradient. The gradient being the change in y over the change in x. So the gradient of AB is the change in y over the change in x. That is equal to f of x plus h minus f of x all over x plus h minus h, which can be simplified to f of x plus h minus f of x all over h. If we now move point B closer and closer to point A, we will eventually reach a point where the chord is exactly the same as the tangent of the line at A. As h tends to 0, we get the limit as h tends to 0 of f of x plus h minus f of x all over h. This is the gradient function of any polynomial. We can now find the gradient function of any polynomial from first principles. Example, find f dash of x of f of x equals x squared plus 3x from first principles. So we know that f of x is equal to x squared plus 3x. Therefore, f of x plus h is equal to x plus h all squared plus 3x plus h. We can now plug our values into our gradient function. F of x plus h minus f of x all over h, giving x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x all over h, which simplifies to 2xh plus h squared plus 3h all over h. We can factorize out h, giving h 2x plus h plus 3 all over h. We notice that the h's cancel, giving 2x plus 3 plus h. We now take the limit as h tends to 0, so the limit as h tends to 0 equals 2x plus 3. Therefore, f dash of x is equal to 2x plus 3. The differential of x squared plus 3x is equal to 2x plus 3.